the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on videos.
Hi guys, welcome to another tutorial of Smart BU Kite on the course Statistics. So today we'll be solving a question on continuous random variable. So here we're having a question which says that suppose that x is a continuous random variable with a probability distribution function. We are being given f of x to be equal to x over 18, the limit from 0 to 6. Find the probability distribution of the random variable y is equal to 2x plus 10. So here is a question on continuous random variable. Let's dive in and see the way we are going to go about this problem. So solution, we know that for a continuous random variable x with a probability distribution function PDF f of x, so the expected value e of x, let's call it e of x, the expected value is equal to integral from infinity to minus infinity x f of x dx. For a probability distribution function y, this is for x. So for y also, with a function f of y, the expected value, which is e of y, is given as integral from infinity to minus infinity y f of y dy. So this is the rules that we are going to be applying to solve this question. So we are given f of x from the question. We are given f of x as x over 18. So here we are also given y is equal to 2x plus 10. So we can look for the y dx. So making x subject of formula here, we are going to be left with, if we make x subject of formula from here, we are going to have x is equal to y minus 10 all over 2. So this is still the same thing as x can be equal to y over 2 minus 10 over 2. So now we are going to find the differentiation, which is the x over dy. So the x over dy is equal to, which is the differentiation of this with respect to y. As you can see here, this one is 0 since it's a constant. Here we are having half, right? So here will be 1 over 2. So the x over dy is equal to 1 over 2. So we are given an expression. There is an expression which says that f of y is equal to the x over dy multiplied by f of x. So here we are given f of x, and we also have our the x over dy, so we can substitute. So now we are going to be left with f of y is equal to our dx over dy is 1 over 2, right? So 1 over 2 multiplied by our f of x is x over 18. So this is equal to x over 36. X over 36. But don't forget, from the expression, because we want, this is f of y, we have to represent it as f of y. We are having f of y is equal to x over 36. But this is f of y, so we have to represent this equation as f of y. So therefore we know that x is equal to y minus 10 over 2. So we are going to substitute x in this expression. So substituting x in this expression, we are having f of y is equal to x, we can say x times 1 over 36, so it will be y minus 10 over 2 multiplied by 1 over 36. So this is equal to y minus 10 all over 2 times 36 is 72. So this is our f of y. So we've gotten our f of y to be equal to y minus 10 all over 72. So this is what we are actually looking for. We want to look for e of y, the expected value, which is the probability distribution of the random variable f of y. We have our y and we have our f of y. What is left is to look for the limit. Our equation is, we said e of y is equal to integral from infinity to minus infinity y f of y dy. So this limit is not the limit of y. So we have to look for the limit of y. Limit for y. So for us to get the limit of y, we have to use x and the equation. We have to use the limit of x and the equation. From the question, we are given that 0, x is greater than or equal to 0 and x is less than or equal to 6. And we are also given that y, the expression, this expression y is equal to 2x plus 10. So we have y is equal to 2x plus 10. So when x, we know that x is having two ranges, so we are going to use these two ranges to find the ranges of y. So when x is equal to 0, we are going to substitute in this equation. So we are having y is equal to 2 times 0 plus 10. So therefore, when x is equal to 0, our y is 10. So substituting for the other one, which is 6. So when x is equal to 6, so we are going to have y is equal to 2 times 6 plus 10, which is equal to 22. We have our ranges for y now, which is from 10, y is greater than or equal to 10, and y is less than or equal to 22. So now we have all the parameters that we need. What is left for us now is to integrate. So integrating, we are having e, expected value of y, integral from 10 to 22. So we are having y, our f of y now is we've gotten our f of y, which is our f of y is y minus 10 over 72. So which is open bracket y minus 10 over 72 dy. So we can further simplify this into, we are having 22 10. So if you open the bracket with y, we are going to have y squared minus 10 y, right, over 72 dy. So factoring out 72, because 72 is a constant here, we are having our e of y to be equal to 1 over 72 integral from 22 to 10, open bracket y squared minus 10 y dy. So now we are going to integrate this now. So integrating, we are having 1 over 72. So before integrating, let's split this into 2, because we know since we are having negative at the middle, we can split this into 2. This integral from 10 to 22 y squared, and minus dy, minus integral again 22 10, then 10 y, then we are having dy. So now integrating the first part, we are having y raised to the power of 3 over 3 minus limit from 10 to 22 also, minus this one also, we are having 10y squared all over 2, limit from 22, we are having 22 and 10. So this is what we are having. So now substituting your upper and lower limits. So opening the bracket with this 72, let's make it let's expand it like that. We are having y cube all over 72 times 3 is 72 times 3 is 216. So limit from 22 to 10. So here also we are going to have 10 y squared all over 144, limit from 10 to 22. So for imputing your upper and lower limits, we can say 1 over 216 open brackets. So the upper limit is 22 cube minus 10 cube minus 1 over 144 open bracket. The lower limit here is, the upper limit here is 22 also squared minus 10 squared. So now further simplifying, we are having 1 over 216 open bracket. So if you compute this in your calculator, you are going to have 99648, and this also 1 over 144. If you compute this in your calculator, you are going to have 384. So our e of y now is equal to 9648 all over 216 minus 3840 over 144. So now if you should press this very carefully in your calculator, you are going to arrive at 18. So therefore this is our final answer. So this is our e of y, which is the distribution of the random variable. So I hope you enjoyed this tutorial. I hope you understand what I've just explained here. If you have any question, you can please drop in the comment section. If you have any recommendation or there's any confusion regarding this question, you can please put it on the comment section. We'll meet in our next tutorial. Thank you.